Greetings and welcome, friends. We were talking about equilateral and isoscelectric triangles. That's not what they're called. We learned some theorems, the base angles theorem and the base angles converse. It says here, if segment AB is congruent to segment EB, so AB and EB, then which angles would be congruent? That would have been angle A and angle BEA. I was going to try to say Bay, but I couldn't. So angle A and angle BEA. And the reason that's true is base angles theorem. That if you have two congruent sides of a triangle, then the angles opposite those sides are congruent. And then it has if angle EBC, this angle, is congruent to ECB, then by base angles converse, the sides opposite those are going to be congruent. So that would be EB, the segment is congruent to EC. You would need those segment tags over those. Let's see, here's question 8. Find the value of x. Well, if these two are 60 degrees, by triangle sum theorem, this is 60 degrees. It's an equiangular triangle. We also know that a corollary to the base angles converse says that if it's equiangular, then it's equilateral. And therefore, all of these sides are congruent. And you guys probably knew 5 minutes ago that x equals 16. Here, the corollary of the base angles theorem says that if it's equilateral, then it's also equiangular. So that means I know that all three of these angles add up to 180. That means that 3x is equal to 60, being a third of 180, and then x is going to equal 20 degrees, or just 20. So there you go there. Not too shabby. I like this one. All right. So let's label what we can here. Base angles converse, these two are congruent, but if possible, I don't feel like correlating those two things because one has an x, one has a y. I also know that by, let's see, base angles converse or its corollary, that because all of these angles are congruent, that then all of these sides are congruent. So what I could say now is that these are congruent by transitivity. So let's start with that. So 5y minus 4 equals y plus 12, and now it's just time for algebra, right? So let's see. So Jordan is all over this problem. 4y minus 4. Oh man, yeah. With the swiftness in that algebra. 4y equals 16. Divide both sides by 4. And y is equal to 4. And now I can relate 3x minus 5 to either of those. I could plug 4 in for either of those to figure out how long that is if I want. I don't know, I'll just say 3x minus 5 equals, let's say y plus 12, which is 4 plus 12 if I substitute. There are a bunch of ways you could have done this. So 3x minus 5 equals 16, plus 5, and we get 3x equals 21. Good old algebra, so reliable. Divide by 3, and x is equal to 7. So the majority of the work here was all algebra, but the geometry was the base angles converse, and then the corollary of the base angles converse. Throw in some transitivity and def of Kong, and we were good to go. Look at this. I was able to get like a picture of a ruler from the internet. So let's see. Where's my... No, we didn't. So let's see. If I want to construct this, let's see. I'm even going to make a weird offset segment. I'm going to pick a point. I'll call this A. And if I want to construct an equilateral triangle whose side lengths are 3, so I start with a ray that I've drawn. Let's see, bam, I'm so glad I figured out that shortcut. Let's measure my compass to be 3 inches. Oh man, I've got to measure it backwards because I can't fit that there. All right, and so what I would do is line them up, and I would swipe here. I could swipe up here actually as well. Go over to this point and swipe up here. and all of those arcs are 3 inches away from one another. I don't know. Was it? I have no idea, actually. The question, by the way, internet audience, was whether or not that was the Blues Clues theme song. I expect you could add in the comments below whether it was or not. I don't know. Or YouTube will tell me I'm breaking some sort of copyright licensing. So yeah, so it's equilateral triangle, and then by the corollary of the base angles theorem, I actually also know that this is equiangular. So once you've done your construction, you could kind of do a check by seeing if your angles are roughly 60 degrees. All right, and then lastly, let's prove the corollary to the base angles theorem. And so I've got statements, reasons, and it said that it follows from the base angles theorem. So they're saying you are allowed to use bat in your proof. I can't use the CBAT, though. That's what I'm trying to prove. So let's see. Let's start with some given information. So like AB is congruent to BC is congruent to AC, perhaps. So that would be the only given information I have for this following triangle. I believe I could then say angle B is congruent to angle C, all right, because those are opposite of these two congruent sides. That would be true by the base angles theorem. I could also prove that angle A is congruent to angle B by the bat. Doesn't like Joker refer to Batman as the Bat sometimes? I think he does. Yeah. So since these are congruent, then that means that this angle and this angle are congruent to each other. And then it looks like by transitivity, I have angle A is also congruent to angle C. So since they're all three congruent to one another, this is by transitive property. Then it is triangle ABC is equiangular. Equiangle. Well, anyways, by definition of equiangular triangle. Bam. So there you go. Nice little proof there. So thanks for watching, internet friends. Adios.